Hi, welcome back. So we're going to continue working with the sums and difference formulas that we did in the last video. And just to show you, here's what they are. The more you work with them, the more they're going to be easier to memorize, by the way. So if we go to example number 7 on the notes, here this is a problem that starts out easily enough where we give the value of one trig function and some other information, and then we try to find all these other trig values, but this time we're doing it with different angles. So here we have the sine of theta is 2/5 and the cosine is negative. So we can use the fundamental identity as we have before. So we know that sine squared plus cosine squared is 1, so we have 2/5 squared plus cosine squared of theta, equals 1. So this is 4/25. Subtract. So cosine squared is 21/25. And because the cosine is negative, we take the negative square root. So it's going to be the square root of 21 or 25, or just negative square root of 21 over 5. Okay. And then as soon as we have the cosine, we can find that the tangent is going to be the sine over the cosine. So it's 2/5 over negative square root of 21 over 5. The 5's cancel, and this reduces to negative 2 over square root of 21. And we won't rationalize because we don't feel like rationalizing things these days, or at least right now. All right, so let's look at the next one. Now here, the only difference is now it's the sine of theta plus pi over 6. Okay, so using the summation formula, this is sine of theta times the cosine of pi over 6 plus the cosine of theta times the sine of pi over 6. And this is, we just found the sine is 2/5. Cosine of pi over 6 is square root 3 over 2. Cosine we found is negative square root of 21 over 5, and sine of pi over 6 is 1/2. We're adding this, so this is going to be 2 square root 3 minus the square root of 21 all over 10, because we have a common denominator here. The secant of theta plus pi over 3. Okay, now of course there's no sum or difference formula for the secant, but we don't need one because we know the secant is just 1 over the cosine. Okay, so this is going to be 1 over. Okay, so we use the formula for the cosine of alpha plus beta. This is the cosine of theta, cosine pi over 3, minus sine of theta, sine of pi over 3, which is 1 over cosine, which that is this number, 1 over 5. Cosine of pi over 3, that's the cosine of 60 degrees, which is 1/2. And we have minus the sine, which is 2/5. And the sine of 60 degrees is square root 3 over 2. So this will be 1 over, then common denominator. So we have negative square root of 10, or negative square root of 21 minus 2 square root of 3 over 10, and this is going to be 10 over negative square root of 21 minus 2 square root 3. and we'll just leave it like that. Okay, and then finally the tangent is tangent of theta plus pi over 4 using the formula for the tangent. This is the tangent of theta plus the tangent of pi over 4 over 1 minus the tangent of theta, tangent of pi over 4. And we just plug. The tangent we found is negative 2 over square root of 21. Tangent of pi over 4, of course, is 1. And we have 1 minus negative 2 square root of 21 times 1. Okay. I guess we could, if we wanted to, we could clean things up a little bit by multiplying and dividing by square root of 21. And what that is this will turn out to be negative 2 plus the square root of 21. And this will be square root of 21 plus 2, I guess. Okay. And leave it like this. We won't go any further because we don't want to. Okay. All right. Now we are moving on to the last page. Notice that we can prove these identities, knowing that how sine and cosine are related. We can see that the sine of 2 pi minus x is equal to cosine of x. We kind of knew that if we plugged in some values like 0 and stuff like that. But to actually prove this, we can do that using the difference formula. This is the sine of pi over 2 times the cosine of x minus the cosine of pi over 2 and the sine of x. Okay, and the sine of pi over 2, of course, is 1. The cosine is 0, and so we just get cosine of x. Okay. Similarly, we wanted to show the cosine, find what the cosine of pi over 2 minus x is. This is the cosine of the difference, so this is the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times the sine of x. Okay. And again, so this is 0, this is 1, and so this is sine of x. Okay. Look at this equation. We're going back to solving certain trigonometric equations. Now, if we had sine theta plus cosine theta equals 0, this was a problem we could do before. Okay, we could just rewrite everything in terms of tangent and go ahead and do that. We can't do that directly here because of this. We have a non-zero number here. So how do we do this? We do a little dirty trick. And it's dirty because I forgot how to do this. I've done this since the last time I taught this class. But the way we do this is that we're going to divide both sides by something. And it looks like we're dividing, but we're actually multiplying by 1 over square root 2. And we'll see why we do that in a moment. Or actually right now. This is going to be, so this will be 1 over square root 2 sine theta plus 1 over square root 2 cosine theta equals 1 over square root 2. Okay. Now, the thing is, 1 over square root 2 is the same thing as square root 2 over 2, which is the tangent, which is the sine of pi over 4, as well as the cosine of pi over 4. Okay, so we can actually write this as the cosine of pi over 4. And this time we'll treat this as the sine of pi over 4. And maybe I'll just rationalize this one just once. And so this is actually going to be the sine of pi over 4 plus theta. Okay, using the trig formula. Okay. All right, so well, what we're going to do is we can't maybe so even if we can't directly solve for theta, we can tell what theta plus pi over 4 is, which is almost as good as the next best thing. And that is if we want to let's say give this a name, let's say if z is pi over 4 plus theta, and we get the sine of z is square root 2 over 2, and that means that z, it has to be either pi over 4 plus 2 pi k, or z is 3 pi over 4 plus 2 pi k. Okay. And then, but z, remember, is pi over 4 plus theta, so then we get, if in the first case, we get pi over 4 plus theta equals pi over 4 plus 2 pi k. So we get that theta is just 2 pi k. That's one set of solutions, where again k is any integer we want. Or we could have pi over 4 plus theta equals 3 pi over 4 plus 2 pi k. Subtract pi over 4, you get 2 pi over 4, which is pi over 2. So theta is pi over 2 plus 2 pi k. All right. So this represents our two sets of solutions, where k again can be 0, plus or minus 1, plus or minus 2, and so on. All right. And what that means is, basically, if you think about it, in the unit circle, the only time where we get 2 points, the only points on the unit circle where the x-coordinate plus the y-coordinate equals 1 is specifically at these points, at pi 0 and pi over 2. So it's this one and this one, not even this one or this one. Okay. 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 So with this involved, let's try to do the last one, where we have a little bit. This is going to be a little bit different, and yet a little bit the same. So here we have 2 times sine plus 1 times cosine is equal to 1. What we're going to do is, instead of dividing by 2, we're going to divide. We know that the square root of 2 squared plus 1 squared is the square root of 5. So what we're going to do is we're going to divide everything by the square root of 5. And what we'll get is then this will be two square root 5 times the sine of theta plus 1 square root 5 times cosine theta equals 1 over square root 5. Okay. And what we have here is that there's some, let's define some other angle phi. We can think of this as the cosine of an angle, and this is the sine of something. We can define phi to be, let's say, the inverse sine, or the inverse cosine, let's say, of 2 over square root 5. So that phi, so that we have the sine of phi is 2 over square root 5, and sorry, should be the cosine of that, and the sine of phi is 1 over square root 5. All right. This, of course, you can always find on your calculator. So what this does is that means now this becomes the cosine of phi sine of theta plus the sine of phi cosine theta equals 1 over square root of 5. And then using our formulas again, this is just the sine of phi plus theta equals 1 over square root of 5. All right. And then if we can solve for this by well, like we can do this by taking the inverse sine of both sides, but keeping in mind there are two solutions. So if we take the inverse sine of both sides, we get phi plus theta equals the inverse sine of 1 over square root of 5. And the other possibility would be phi plus theta equals pi minus the inverse sine of 1 over square root of 5. Okay. And, so this is going to be, well, at this point you can, and maybe I should put plus 2 pi k. And I'll say that I will leave it for you to finish, but we know that phi is known. We can find a calculator for phi, so we could just say, like from here we could say theta would be minus phi plus the inverse sine of 1 over square root 5 plus 2 pi k. And the same thing over here. Okay, you could find out what the other solution was. Theta would be minus phi plus pi minus sine, inverse sine of 1 over square root 5 plus 2 pi k. Okay. And you can use your calculator to find out what these things are. So there's a little trick, and if you look at the last example in your book, you can see what the trick is to do that. So go ahead and try working these out. Get lots and lots of practice. Memorize those formulas. Have fun if you can, and I'll see you next time.